talk about differentiation and integration of the exponential function. If you want to take the derivative with respect to x of any function, of e to any power, if you want to take the derivative with respect to x of e to any power, you get back e to that power times the derivative of the power. For example, if you want to take the derivative with respect to x of e to the 2x squared plus 5x, well, since this is e to a power, you will get back e to that power. Do not get that part wrong. You will get back e to the power times the derivative of the power. The derivative of 2x squared plus 5x is 4x plus 5. Now suppose you're told that y is equal to e to the 1 minus x squared, then the derivative will be e to a power. The derivative of e to a power will be e to that power times the derivative of the power, which is negative 2x. There's the answer. The derivative of e to a power is e to that power times the derivative of the power. If you want to take the derivative of e to the x squared over x, well, this is a quotient problem. It's a division. Use the quotient rule. I'll just denote what the steps are, and then I'll do it. Y prime equals the derivative of a fraction. It's the derivative of the top. I'll denote it by saying prime times the bottom minus the top times the derivative of the bottom all over the bottom squared. Now let's do the calculus. E to the x squared prime. That means the derivative of e to the x squared. Well, the derivative of e to the anything is e to the anything times the derivative of that anything. In this case, derivative of x squared, which is 2x, times x. It doesn't say to take the derivative of x. Times x minus e to the x squared. Once again, no prime. E to the x squared times the derivative. It does say prime. The derivative of x, which happens to be 1. And all of this is over x squared. Well, it's always going to happen when you have an exponential function that you're going to have e to the x squared in both terms. If you're taking the product, if you have a product rule that you're using, or a quotient rule. Why? Because whether it's a product or a quotient, first you are going to take the derivative of e to the x squared, which will give you e to the x squared, and then in the next term you're not taking the derivative of e to the x squared, which will give you e to the x squared. So I can always factor that out. 2x times x, 2x squared, minus the understood 1. We have to have e to the x squared times 1 in order to get back e to the x squared. And all of this is over x squared. The derivative of e to any power. So whenever you need to take the derivative of e to a power, whether it's in the product rule or in the quotient rule or in the general power rule or a combination of them, the derivative of e to any power is e to that power times the derivative of the power. If I told you that y was e to the negative x plus e to the x to the 7th power. Well, this is a function to a power. We use a general power rule. We keep the function the same, and we play games with the power. We bring down the power, we make the new power 1 less. And then do not forget to take the derivative of what's inside. Well, the derivative of e to the minus x, well, it's e to the minus x times the derivative of the power, which is minus 1 or just minus, plus the derivative of e to the x is e to the x times the derivative of the power. The power is x. The derivative of x is 1. There's no need to write the 1 in front. And there's your answer. Now, there's the answer. I was thinking maybe these bases were the same, but they aren't. Because this is minus e to the minus x, and this is not. It's just e to the minus x. So that problem is done. Sometimes you have a power problem, a function to the power, and you use the general power rule. And when you want to take the derivative of something, if it has an exponential function, then you use the rule I've been stating. If you're told that y is 2 over e to the x plus e to the minus x. You can use the quotient rule here, but I don't think once you use the quotient rule, it's either the top or the bottom. It's just a constant. In our case, the top is a constant. Remember, the exponent here is 1. What I would do is I would bring the bottom to the top, but of course I would change the sign of the exponent. Now I use the general power rule. I keep what's inside the brackets the same. I bring down the negative 1. I multiply it by the 2. And I make the new power 1 less. 1 less than negative 1 is negative 2. And now I take the derivative of the inside. The derivative of e to the x is just e to the x. Because the derivative of e to the x, by our rule, is e to the x times the derivative of x, which is 1. But 1 times e to the x, e to the x. Plus, the derivative of e to the minus x is e to the minus x times minus 1. And there's your answer. Well, we shouldn't have negative exponents. Since that exponent is negative, I'll put this factor in the denominator. E to the x plus e to the negative x to the second power. And the 2 I'll put on top. Now the minus I'll distribute in here. That is, instead of e to the x minus e to the minus x, I write it backwards. This minus sign is like negative 1. If you take e to the x minus e to the negative x, and you multiply by negative 1, of course you can distribute here first and then here. But I would go here first. A negative times a negative is a positive, and 1 times e to the negative x, of course, is e to the negative x. And negative 1 times e to the minus x is minus e to the x. And minus some silly error, that's just what I wrote down here. So here is the final answer, the cleanest version of it. Do not get caught up by exponential functions. You have y is equal to x squared, e to the x cubed, plus 7x to the fifth times e to the x cubed. You want to take the derivative. Well, it's the derivative of this, like always, plus the derivative of that. The sum rule. You have the sum and you want the derivative. The derivative of the first plus the derivative of the second. But the first is the product. It's x squared times e to the x cubed. So, again, I call x squared the first and e to the x cubed the second. The derivative of the first times the second plus first times the derivative of the second. The derivative of e to the x cubed is e to the x cubed times the derivative of x squared. Excuse me. The derivative of x cubed, which is 3x squared. That part is done. Plus, now you can factor out the 7, or you can call 7x to the fifth the first term, and e to the x cubed the second term. So it's the derivative of the first term times the second. E to the x cubed times the second. Plus the first, 7x to the fifth, times the derivative of the second. So e to the x cubed times 3x squared. Now we just clean this up a little bit. The first thing I notice is that I keep saying in each and every term e to the x cubed. I also see an x in each term. So I'll factor out e to the x e to the x cubed. So in here, I factored out the x and the e to the x cubed. I'm left with 2. Plus, over here I factored out e to the x cubed, and only one of the x's here. So I have x squared times that remaining x, which is x cubed. And I also have this 3 left over. Plus, I factored out the x cubed. I factored out only one of the x's. So I have x cubed left. And let's not forget the 35. You want to do the numbers first. 7 times 3, 21. I factored out one of those x's, so I'm left with x to the fourth over there, times x squared. Well, that's x to the sixth. And I did factor out the e to the x cubed. And there's my answer, and I look inside the brackets to see if anything can be factored. The answer is no. There's no x's in the first term, so there can't be x's in every term. It's not in the first. And the only number that goes into 2 is 2, and 2 doesn't go into 35. So I couldn't possibly be able to factor 2 out from every term, because I can't factor it out from 35. For the record, I can't factor it out from the 3, nor the 21. So minus a silly calculation error, there's the answer. You have a product, and it has exponential functions, no big deal, use the product rule. If you have a quotient, use the quotient rule. Suppose you had x e to the y minus 3x plus 2y, and this is equal to 0. The instruction asks to find dy dx. Okay? Thus the derivative of this minus the derivative of that plus the derivative of this, and it's going to equal the derivative of that. Well, the first terms are separated by addition and subtraction symbols, and I guess the equal sign. The first term is a product, so it's the derivative of the first times the second minus the derivative of the second. This is with respect to x, plus the derivative of 2y with respect to x. Probably prime isn't the best thing to write, but I'm writing it, and I do have a typo. So, why didn't this erase well? Okay, so let's try this again. It's the derivative with respect to x of x times e to the y, the second term. Second factor, excuse me. Plus, this is the product rule, it's just x times the derivative with respect to x of e to the y. Okay. Minus the derivative with respect to x of 3x plus the derivative with respect to x of 2y. And this is going to equal to the derivative with respect to x of 0. The derivative with respect to x of x is, well, the derivative of x is 1. X is in terms of x with respect to x. That is, this cancels and you just get 1 times e to the y plus x times the derivative of e to the y with respect to x. The derivative of e to any power is e to that power times the derivative of y with respect to x. Well, it's 1. It's in terms of y. E to the y is in terms of y with respect to x. Minus. The derivative of 3x has always been 3. 3x is in terms of x with respect to x. Coincidentally, that cancels. Plus, the derivative of 2y has always been 2. But 2y, it's in terms of y, it's only variable y, with respect to x. And the derivative of 0 with respect to anything is 0. So multiplying this together, you get e to the y plus x times e to the y times 1 is just x e to the y times dy dx. I'll write dy dx that way. Minus 3 plus 2 y prime. And this is equal to 0. I bring all the y primes to one side. I bring everything else to the other side. I'll keep the y primes on the left side. So I have plus e to the xy plus 2 more. Plus 2 more y primes. And I bring everything else to the other side. The minus 3 becomes 3, and the e to the y becomes minus e to the y. And then in the top right corner, I just divide by x e to the y plus 2 on both sides. The left side just gives me y prime. That's why I divided by this. The right side will just give me what the right side was over x e to the y plus the number 2. And there's your answer. Even if it's an implicit problem. Just the fact that it has the exponential function should not make it any harder. If you were asked to find the extremer and the point of inflection, you can do that. Suppose you have y is equal to x squared e to the minus x. So we want to find their extremes and point of inflection, if any. Extremes or maxims. Take the first derivative, see if it equals 0. Those will give you possible maxims. I take the first derivative, it's a product. Derivative of the first is 2x times the second factor plus the first factor times the derivative of the second, which will be minus e to the minus x. And then I'll factor out e to the minus x. In fact, I can even factor out an x. So I factored out e to the minus x from the first term, and I factored out an x. What goes in the bracket is a 2. Now, plus times a negative, that's a negative. I factored out e to the minus x. There it is. And I factored out one of the x's. So I have another x remaining. At e to no power ever equals 0. So this equals 0 if when this is 0 or when that's 0. Well, x is 0 when x is 0. And 2 minus x is 0. Well, you all should know that 2 take away 2 is 0. If x is 2, then we have 2 take away 2, which is 0. The x is 2. And again, this is never 0. Okay, e to the negative x is never 0. So here are the x values of the possible extremes. Now let's look at the first derivative. The first derivative is x. The first derivative is right here, nice and clean looking. I don't know why I'm looking elsewhere. Okay, here is the first derivative. If I plug in a number a little bit less than 0, the second factor will be positive, it always is. If you just a little bit less than 0, 2 minus close to 0 is always positive. But the first term, x, will be negative. Okay, so the overall result is negative. This is where x is less than 0. Let's look at when x is more than 0. Just a little bit more than 0. If x is a little bit more than 0, well then x will be positive, and e to the negative x is always positive. And if x is anywhere near 0, like 0.0001, it's going to be positive. So we know we're positive. Since the sign changed, we do have an extrema. We know that to the left is 0, the slopes are negative. When x is less than 0, the derivative is negative. And when x is more than 0, the derivative is positive. So we have a min at x equals 0. Okay, so we have a min when x is 0. And if you go back to the y equation, you can find the y value. 0 squared is 0. And 0 times e to the negative 0 is 0. So we have a min there. Now let's go on to the other critical value, x equals 2. Let's look at x is, say, less than 2. That means x will be negative, and e to the negative x is always positive. If you're a little bit less than 2, 1.999, if you have $2, you can spend less than $2. You'll have something left over. So the overall product was negative. Now, if x is bigger than 2, well then x is positive. Okay, I don't know why I put down negative right above. Sorry. If x is less than 2, a little bit less than 2, then it's positive. So it should have been positive at the end. Sorry. If x is more than 2, well then x is positive, and e to the negative 2 is positive. And if you have 2, and you take away more than 2, well now you're negative. If you have $2 in the bank, and you convince them to let you take out $2 in a nickel, well you're negative. You took out more than $2. So the overall sign is negative. What this is telling me is to the left of 2, the slope is negative, positive, slope is positive, I'm going up. And then more than 2, to the right of 2, the slopes are all negative, going down. You have a max. You have a max when x is 2. And I plug it in. You get 2 squared is 4. Now remember, this is the same as x squared over e to the x. So over Okay, so I found the maximums. Now we're going to go on and find the critical values. Excuse me, the point of inflection. Now, here's a rule that you should know. It really makes your life easy. If you have many functions, 3 functions, 4 functions, and you want the derivative, what you do is you write down the 4 functions 4 times. If you had 3 functions, you write it down 3 times. You write it down 4 times in this case. And then you take the derivative. You go in the first factor, you take the derivative of one of them, say L. And then in the second term, you take the derivative of a different one, say G. And then in the third bracket, a different one from the first 2. And in the last one, you take the derivative of J. That's how you find the derivative of a product of 4 things. We have 3 factors for y prime. Y prime equals the product of those 3 things. So, the second derivative, that's how you find the point of inflection. You look at the second derivative. And the rule I stated just now works for any number of functions. It even works with 2 functions. If you want the derivative of 2 functions, well, write it down 2 times, all with pluses. Take the derivative of the first one, and take the derivative of the second one. So that's just what we're going to do. We'll do it nice and slowly, and we'll get it. Write it down 3 times. First, I'll take the derivative of x in the first term, and then in the second term, I'll take the derivative of e to the minus x, and in the third term, take the derivative of 2 minus x. The derivative of x is 1, so I get e to the minus 2x times 2 minus x plus, I have x isn't going to change, and 2 minus x will not change. The order you multiply things does not matter. So now I have to take the derivative of e to the minus x. Well, what that's going to become is minus e to the minus x. X doesn't change, e to the minus x doesn't change. This changes. The derivative of 2 minus x is minus 1. So adding minus 1 is the same as taking away 1. The last thing I'll say is they're all going to have e to the minus x. 2 minus x minus this. Minus 2x and minus a negative x squared. That is plus x squared. Minus 1x. Minus x. Okay, let's go to the top. Letter C. Let's clean this up and see when it equals 0. Because that's going to give us our possible point of inflection. Y prime is e to the negative x times, well, 2 is just 2. And if you take away x, and you take away 2x, you take away 3 x's. And if you take away another x, you take away 4 x's. And do not forget to add the x squared. Okay. And I don't know why the y prime didn't come out. Y double prime equals the next line. There we go. Y double prime. Now the question is, can we factor plus x squared minus 4x plus 2? Can we factor that? Can you think of two, since it's a 1 in front, I'll ask myself, can I think of two numbers and multiply out the 2 and add up to -4? The answer is no. The only numbers I know to multiply out the 2 are 1 and 2, or -1 and -2. I'm going to hope that that never equals 0. Let's look at the discriminant. That's A, that's B, and the constant is 2. So it's -4 squared, which is 16, minus 4 times A times C. Okay, that's going to equal 8. So what is actually, so this is 8, because that's 8, and 16 minus 8 is 8. So we know that x is equal to -b, which will become plus b, plus or minus the square root of b squared minus 4ac, which we just discovered was 8. And this all gets divided by 2a, which is 2. 2 times 1 is 2. So we get 4 plus or minus. Now 8 is 4 times 2. So the square root of 8 is the square root of 4 times the square root of 2. And personally, that's how I write the square root of 2. And this is over 2. So we can factor out a 2 from the top. We have 2 times 2 gives you 4, plus or minus the square root of 2. Because the 2 in front times the square root of 2 gives you 2 square root of 2. And this gets divided by 2, and what we get is 2 plus or minus square root of 2. Okay, so this is a mess. What this here tells me is the way to factor that bracket that remains is as follows. So of course we're not going to forget to use a minus x. We get x minus one of the zeros. One of the zeros is 2 plus square root of 2 times x minus the other 0, which is 2 minus the square root of 2. So what we get is, what I'm saying is all true, but we just want to know when it equals 0. Excuse me. We just want to know when it equals 0. We didn't need to do the factoring. Okay, it's a long problem. So this is equal to 0 when x is equal to 2 plus or minus the square root of 2. That's when this equals 0. Either the negative x never equals 0. Okay, now, since those are not critical values, it must be a point of inflection. Okay. So, we have a point of inflection at 2 plus square root of 2, and I guess we should find the y value, and at 2 minus square root of 2. Okay. Let me erase most of this work. And then we'll try to remember what the function was initially. And that's just the x value. If I'm not mistaken, this here was the function, which is the same as x squared over e to the x. So, it's x squared. It's 2 plus square root of 2 squared over e to the x. 2 plus square root of 2. That's one point. The other point is x squared. Here's the x value. So x squared is just x squared over e to the x. Those are the 2 points of inflections. Everything I put down had the x and the y value. Put them in, we found the x's, so we went back and found the y values. So now you have a chance to draw this function. So I'll leave that as an exercise. Okay. Let's go on to integration. Remember, the derivative of x is e to the x. Well, let me write that. The derivative of e to the x is e to the x. The derivative of e to the u is e to the u times du dx. Now, if you remember that, you're in good shape if you don't remember how to integrate these things. The derivative of e to the u is e to the u times du dx. That we know. We know that. Except I need a little bit more space. Derivative of e to the u is equal to e to the u times du dx. Whether you write the du dx in front of e to the u or after doesn't matter. Now, if I integrate both sides with respect to x, the dx's cancel, and the right side is the integral of e to the u du. On the left side, the dx's cancel. Now, the integral of d of anything is just d of anything. And when you integrate, you get a constant. That is, the integral of e to the u times du is e to the u plus a constant. The integral of e to the u du is e to the u plus a constant. But you better have e to the u du, not the integral of e to the u and not du, something other than du. That will not make it. You have the integral of e to the x squared times 2x dx. Generally, if I have a problem that looks like that, has an exponential on e, I let u equal a power. If I let u equal the power, well then du will equal 2x dx. Okay? Be honest with yourself. Don't just hand wave. Make sure you have everything you need. Well, that of course is e, and I'm calling that u. And what do you know? Dx, 2x dx, that's du. The integral of e to the u du is e to the u plus e, where u is x squared. E to the x squared plus c. Do not just assume that's du. It may be, it may not be. Don't assume it. When you convert from x's to u's, you have to make sure you justify everything. You have the integral of e to the negative 2x dx from 0 to 1. Again, I would let u equal what's the power? Let u equal negative 2x. Well then du is negative 2 dx. Well, this part here is clear as day. It's e to the u. But dx, if only I had a negative 2. If only I had a negative 2, then I can call that du. But to justify multiplying by negative 2, I have to multiply by the reciprocal. So I have negative a half times the integral of e to the u du. Well, I know what that is. That's e to the u. So I have negative 1/2 e to the u plus c. Where u is, and don't randomly guess, go back and look. Negative 2x plus c. Now, some of you may be saying, well, this here is e to the u plus c. Why aren't you multiplying everything by negative a half? Fine. Negative a half times e to the u, that's negative a half e to the u. And negative a half plus the constant is just plus a constant, a different constant. You don't need to multiply the negative a half by the constant. And if you do, you get a different constant. How about, so back to that last problem, the integral of e to the negative 2x dx, we realized was negative a half e to the negative 2x. Let me double check that, please. Okay. So we had to integrate from 0 to 1. 0 to 1. The first thing I would do is I would realize that that's negative 1 over 2 e to the 2x. Let's write it bigger, please. Okay. Because this has a negative exponent, it's in the numerator, I can put it in the denominator. Now, I also hate negatives, so I'm going to make it positive. I'm just going to change it. Done, changed. But when you change it, you have to swap the limits. Instead of going from 0 to 1, you go from 1 to 0. Now, you plug in 0. You get 1 over 2. Because 2 times 0 is 0, and e to the 0 is 1. And 2 times 1 is 2, just what I wrote down. Minus. Now you plug in 1. The top is 1. The bottom is 1 is 2, e to the 2. 2 times 1 is 2. You want to get a common denominator, you could put e squared on the bottom over here. So now they both have 2e squared. If you put e squared on the bottom, you have to put it on the top. So you have 1 times e squared, which is e squared minus 1. And if you wanted to, you can even factor that. The difference is squared. E is being squared, and 1 squared is 1. 1 is being squared. So it's e plus 1 times e minus 1 over 2e squared. Either one of those would be, in my opinion, a complete answer. But I really wouldn't leave it here without the e squared. We should get a common denominator. You have to get e to a power times the differential of the power. du is called the differential. There's a nice one. E is the 3 over x divided by x squared from 1 to negative 3. Make that positive. Again, I would generally let u equal the power. I would let u equals 3 over x, which I'll write this way, because I'm kind of going to be taking the derivative. Kind of, because we're really finding the differential, which is exactly finding the derivative of this, but then saying times dx. I bring down the power, it becomes -3, and then I make the new power 1 less, but no negative exponents. So I put it in the bottom. That's what I did. There's a typo, it should say dx. Okay, so this piece right here, that's e to the u. And du over x squared is almost what I have. If I just multiply by -3, well then that is du. But I have to counter that. I have to divide by -3, or multiply by -1/3. -1/3 times 3, -3. First I would do the sign. Negative times a negative is a positive. Now all I do is I calculate 1/3 times 3. No more signs anymore. The sign is in front. The third is 3 is 1. You get positive 1, which is what we want. You can only multiply by 1. Okay. So I have the du, but I also have 1/3 in front. And then it's a routine. The integral of e to the u du is e to the u plus c. I'm not going to guess what u is. I wouldn't dare do that. Okay, it's not plus c only because we know what it's a definite interval. It's from 1 to 3. Again, I would not go from 1 to 3. I would go from 3 to 1. Why? Because I hate that negative in front. Plug 1 in, 3 over 1 is 3. The third's going to factor out. I hope you see that. You plug 1 in, you get e to the 3. Minus, you plug 3 in, 3 over 3 is 1, and you get e to the 1 or e. And there's the answer. I guess you can factor out an e. And then you get e squared minus 1. Didn't expect that to happen, but this here, for e squared minus 1, that's the difference of squares. E is being squared, and you can think of 1 as being squared. E and 1 are being squared, they go in separate brackets, twice e and 1. 1 gets a plus, 1 gets a minus. Okay. Actually, I would write it as such. I would put that 3 in the bottom. It's a very nice answer, looking answer. Here's the silly problem. How about an integral from -2 to 0? That's 3 to the 4th. I don't know, minus 5 squared dx. Okay, this is not exponential, because these are constants. 3 to the 4th just happens to be 81. 3 times 3 times 3 times 3. Well, that's 9 times 9, or 81. Minus 5 squared is 25. And if you do some subtraction, you get, I think, 56. 56 dx. The integral of 56 dx is just 56x. Quick check would be the derivative of 56x is 56. And this goes from -2 to 0. First you plug in 0. I backed it out to 56. That is, I'm doing this. Minus, and then for x you plug in -2. Don't say I already put the minus. No, you didn't. So it's 56 times 2, or 112. Remember, you can change the operation anytime you feel like it, as long as you change the sign of the second number. 0 plus 2 is 2. 56 times 2 is 112. Okay, let's try one more type of problem. Finding the area. Find the area bounded by y equals e to the x, y equals 0, x equals 0, and say x is equal to 5. Find the area bounded by these curves. Okay? Let's do that. An integral problem. We just set up the integral. Y equals 0 happens to be the x-axis itself. X equals 0, that happens to be the y-axis. X equals 5 happens to be this line here. And e to the x happens to be this. So we want the area bounded by what you see in red. That is, it's the area that you want needs to be trapped. You can't go anywhere. For example, you can't go to that point there if you're in that area. If you're over here, you can go there. If you're over here, well, you can go there. If you're over here, you can go there. But if you're in here, you can't go. Okay, I think you realize I didn't like what I said because these lines go down forever. So I really couldn't go that way. But I never really realized that point. Okay. So let's say it again. If you're in here, you can go forever. You can go down. You can't go up, but you can go down forever. You can go up forever. You can go to the left forever. You can go forever. But if you're in that middle, you're stuck. If you're in the middle, you're stuck. That is the bounded region. Okay, the bounded region is the area I'm erasing right now. Okay, so let's integrate. It's the integral from 0 to 5. That is, if you're going to draw the rectangles, you're going to draw those rectangles, you start at 0, x is 0, and you finish where x is 5. And it's the top of the rectangle, which is e to the x, minus the bottom of the rectangle, which is 0, y is 0. E to the x minus 0 is just e to the x dx. Ooh, simple integral. The integral of e to the x dx is just e to the x. And you go from 0 to 5. So you get e to the 5 minus e to the 0. When you put 0 in for x, you get e to the 0, which is 1. There's your answer. That's the exact area in here. Okay? Square units. Square units. If your units were feet, you'll have square feet. That is, from 0 to 5 was 5 feet. You'd have e to the 5 minus 1 square feet. Okay, hopefully this is helpful. And this also completes this section.